Orlando Solis from Advanced Quantitative Reasoning. So I'm just going to be doing a couple of things, talking about future values. So I'm going to go ahead and introduce you to everyone here to a new tool, and this is a really cool thing to do. So first off, let me go and bring this up. I brought up a calculator. I'm going to bring up another one, of course. And then you have menu. And if you look right here, we're in the finance section of our units. So right here, we have something called the finance solver. So big N stands for the number of periods. So if, say, for instance, you have something compounded monthly, so that takes the year, divides it up into 12. So it's 12 months out of a year, or 12 periods. So in order to find the total number of periods, we take, for instance, 2 years times 12, and as you can see right here, as soon as I hit the tab button, it automatically calculates 24. Now we have interest. So that's just a percentage, and you don't need to go ahead and convert this to a decimal. It just works on the actual percentage. PV, that stands for present value. That's going to be a negative number for investments. But say, for instance, if you have debt or a loan, that number is actually calculated as positive because that's money given to you for whatever you're going to use it for. Then you have to pay, of course, pay it off. And for like an investment, it has to be a negative number because you're pulling money out of your pocket, putting it in the bank, and you don't have that available for your use. Sorry. Then we have PMTs, so that's payment. And payments are always going to be negative, even when you have an annuity. So you're taking money out of your pocket, putting it inside the bank, and that's about it for that. Future value is going to be a positive number, but if you're talking about debt, that's actually going to be 0. You're going to be paying this off. Payments per year, that's going to be payments per year. And so that's saying, well, if you are compounding monthly, well, that's going to be 12 payments per year. Then you have compounding periods per year. So it's the same thing, compounded monthly, well, 12 payments per year, or 12 compounding periods. And this is payment at. It's either payment was done at the end of the compounding period or at the beginning of the compounding period, because you can change that to begin. So we're going to leave it at end. So as you can see, this is really an easy tool to use, and I'll go over the specifics. And I'm going to be using this particular example. What is the balance of the account at the end of 10 years if $2,500 is deposited today and the account interest rate is 1.67% compounded monthly? So let's see, we have 10 years times 12. So remember, that's big T times little n. Then you have the compounding, the interest rate, so 1.67. Our present value is a negative 2500. Remember, that's an investment. You no longer have that available. Payments are 0 because we're not making any payments. Future value, we're going to find that out. This is compounded monthly, so we change that to 12, and of course that also changes automatically, so you don't have to worry about it. So then we just hit tab. I suggest using tab because the tab key can traverse this very easy. Then when you're at the place where you want to solve for, which is FV, you hit enter and it automatically does it, and everything gets bolded. And so that's $2,954.04 that you need to deposit today in order to go ahead and get, no, not deposit. That's what your investment will be grown to. Okay? And that's it for that. So that's future value. Let's take a look at present value. Let's see, present value. So sometimes we need to find out what the present value. We need to calculate the present value. So we're going to use this particular one. So let's see, calculate the present value of of 1,500. So we're going to go ahead and say that this is the future value, 1,500. Let's see, compounded. Okay, so it's compounded annually. Well, no, I don't like this example. Let's just go to the next one because I need some compounding. Okay, so this is going to be the one. How much would you have to deposit in the account today that pays 12% interest compounded quarterly? So let's see, we have 10 years times the compounding, which is 4. And then you have 12% interest. We have a no PV because we're trying to figure that out. So you can either delete that and leave it blank or whatever you want. FV, we need that built up to $20,000. We're going to leave that at 4. Okay, so that's the compounding periods, and now we're going to be calculating the PV. So that's $6,131.14 that you would need to put into the account today in order to build up to $20,000. And that's how that works. Okay, and so that's the end of that one. So next, we're going to be looking at annuities. Also debts. So let's see, future value. Yeah, annuity. So I'm looking at the practice here. All right, in order to buy a house, and let's see, in a new house, a family obtains a mortgage. Oh, wait a minute, I don't want to talk about that one. Loans, credit cards. All right, here we go. I am setting up a fund for my son to go to college. I figure that he needs $50,000 by the time he is old enough to go to college. So we want this to pay out $50,000. Okay, I found an account that pays, let's see, 5.75%. As you see, I'm filling this out as I'm recording, as I'm doing this. The compounding rate is okay. Interest rate compounded monthly, so it's 12. All right, and we're not going to begin with anything for our beginning balance because we're going to begin with payments. And let me see, he's going to be saving for 17 years because right now his son is 1 year old, I bet. So that's 17 times 12. So that's 204 compounding periods for the total 17 years. Okay, and so we're just going to look at payment. We just want to see what the payment's going to be. So that annual payment is going to be, let's see, 100. So the payment PMT is going to be $145.06 per month for the next 17 years. It may seem high, but you know what? To make that much money, you have to put in that amount. And 5.75% is actually a really good rate. Now, let's talk about a mortgage. In order to buy a new house, a family, and this is a debt, this is a loan, a family obtains a mortgage of $150,000 for 30 years at 7.5% compounded monthly. What are the monthly payments? What is the example? Okay, is this an example of annuity or no, that's annuity due. This is a loan. So that's an annuity due. So we have 30 years times 12 years because it's compounded monthly. So that's 7.5%. We have a mortgage, so this is 150,000. Remember, PV is going to be positive because this is money that was given to you to go buy that house, that $150,000 house. I mean, it may seem pretty high, but you know what? We have to do that. Let's see what the payment's going to be for that. Future value is 0. So credit cards, any kind of debt, any kind of loans that you're paying off, we want to pay it off till it's 0, no money. Let's see, 12, so that everything is set up. So PMT. So the payment on the house at 7.5% is going to be approximately 1,000. Okay, so let's see. That's going to be approximately 1,000. So payment $1,048.82. Now, I'm going to tell you something about mortgages, and because this is what they don't tell you, is that you have to pay for extras. Number one, you have to pay for the taxes for the year. That's done in an escrow account, so that's added on to this. Though that may be about, I don't know, about $100 a month. Then you also have to pay for the insurance on the house. So that's extra. So you're not only paying $1,000, but you're paying for insurance and other fees that may occur. So the payment, this is just a payment towards the principal. This isn't your final word on how much you're going to pay on the house. So you need to do a little bit more research on this if you wish to buy a house. Don't take this as 100% done. And that's how you calculate debt, annuities, and all this using the finance solver from your TI Nspire. It's really, really a good tool, and thank you for listening. Bye.